Antarctic Glacier retreat sparks urgent scientific debate. Antarctic Glacier retreat sparks urgent scientific debate. A recent study has ignited a debate within the scientific community about the mechanisms driving rapid ice loss in Antarctica. At the heart of the controversy lies Hectoria Glacier, which experienced an unprecedented retreat of over 8 kilometers, 5 miles, in just 2 months during late 2022. While the extent of the glacier's change is undisputed, scientists are divided on the cause, raising crucial questions about the future stability of Antarctic ice sheets. Hectoria Glacier's dramatic shift began after an earlier collapse of the Larsen B ice shelf in 2002. This event freed Hectoria from the restraining influence of the shelf, causing it to speed up and thin. The resulting gap was partially filled with sea ice anchored to the seabed, temporarily stabilizing the glacier. However, this stability shattered in early 2022 when the sea ice broke apart. Subsequently, large chunks of floating ice, icebergs, calved from the glacier's front as the underlying ice flowed faster and thinned, a natural process accelerated by human-caused climate change. This phase is not unusual in itself. It's the subsequent event that has scientists puzzled. The crux of the debate centers on whether Hectoria's front was grounded, resting on the seabed, or floating when it underwent an astonishing retreat in late 2022. Lead study author Naomi Achwat, a research affiliate at the University of Colorado Boulder and postdoctoral researcher at the University of Innsbruck, and her team argue that the glacier was grounded, encountering unprecedentedly rapid retreat for such a scenario. They propose that upward forces from ocean water pushed against the thinned ice resting on a relatively flat bedrock area called an ice plain. This force could have triggered sudden calving and rapid retreat. However, other glaciologists contest this interpretation due to uncertainties about the precise location of Hectoria's grounding line, the boundary between grounded glacier and floating ice shelf. Dr. Christine Batchelor, a senior lecturer in physical geography at Newcastle University, emphasizes that if the affected section was actually floating, the calving event would be less extraordinary. Despite this disagreement, there's near universal agreement on one critical point. Antarctica is changing faster than previously predicted. While we disagree about the process driving change at Hectoria, we are in absolute agreement that the changes in the polar regions are scarily rapid, quicker than we expected even a decade ago, said Anna Haag, professor of Earth observation at the University of Leeds. She stresses the urgent need for enhanced satellite monitoring to better understand these changes and their implications for global sea level rise. The fate of glaciers like Hectoria is directly tied to the fate of the world's coastlines. If similar processes occur elsewhere in Antarctica, particularly at vulnerable locations, such as Thwaites Glacier, dubbed the Doomsday Glacier due to its potential to raise global sea levels by 65 cm, the consequences could be catastrophic. Further investigation into these seemingly small-scale events is crucial for grasping the broader picture of Antarctic melt and its profound impact on our planet.